Hello everybody, my name is Ben Cartwright-Cox and this is the unending misery of bgp.tools. bgp.tools, if you haven't seen it before, basically looks like this. It's effectively an internet debugging system for your config to get to see how the rest of the world sees your network from all of my peers' point of view. It is sort of directly, not competing, but sort of trying to make a better user experience from things like, the root views, telnet servers, and the other Hurricane Electric website, which actually part of my reasonings for creating bgp.tools in the first place was knowing that a site like Hurricane Electric, very decently good bgp.he.net exists, but wasn't quite good enough. It had a few shortcomings. One of the things that I've become obsessed with is ensuring that the experience for this kind of stuff is good on mobile, because nothing is worse than potentially getting called either asleep or in the middle of the pub and saying, something is down, and saying, okay, well, what does the customer's side look like? Are they still on the internet? Being able to look that up on your phone rather than having to whip a laptop out is significantly appreciated. A whole bunch of quality of life tools also exist on bgp.tools. For example, this is showing a single prefix. I do nice things like, for on IPv6, it tells you about that partition that exists. It also tells you things like the individual upstreams and peers per prefix rather than on a sort of network aggregation level, which is sort of supporting the idea that most modern networks don't have a contiguous announcement policy. So they don't just announce all of their prefixes, they don't backbone everything. And so they have like small little network islands is becoming significantly more common, especially in the CDN space. It also handles a whole bunch of really annoying edge cases, like this wonderful, absolutely beautiful VeriSign prefix that has at least 22 different originating ASNs. This is one of those inconvenient truths for most BGP data processing, in that there's a humongous assumption that one prefix has one ASN. Not for this. Surprisingly common tactic, but yeah, many things to say about this kind of tactic. Going on a bit earlier about the whole contiguous networks not really being a thing anymore, or contiguous announcement policies not really being a thing anymore. So networks are automatically broken up into detected policies. So if a group of prefixes are announced the same way to the same people, they are all bundled up into a prefix with a semi-automatic name assigned to it. There's no real meaning to these names, which helps you quickly page through. So if you have a South African pop, a London pop, and a US pop, you can probably individually bring all those prefixes out in the policies, one by one. It avoids situations like this, like on the Hurricane Electric site, where if you take a very big ASN and click the graph, you get what I call graph-ist routing spaghetti, where that is completely unreadable, just not intimidating and not really worth bothering at. And one of the key ideas of the site is specifically to ensure that if I do give you a piece of data that you are aware of when was it produced, when was the sort of authoritative, when did I see it? And so the site has last fetched by certain times, but also has an entire page basically dedicated to when was the last time that cron tab ran, when was the last time I downloaded some data. One of the other things is I like to get a little bit more adventurous for data sources than I think most people are willing to go. For example, on links and most other major IXPs, I have either myself or a whole bunch of people feeding me ARP data. So you can click on an ASN and see immediately what vendor their IX ports are. So if they are using Huawei Kit, you can see that. If they're using Juniper, like seemingly most people on most internet exchanges are now using, you can get that insight. Obviously, they can change this. So a couple of people on links are using things like Raspberry Pis. I somehow doubt that they are directly plugging links into a Raspberry Pi, but if they are, cool, I guess. As well as that, I actually do scan the entire internet every 30 days or so on v4. Everything is pinged, so that you can click onto a prefix and see if there is anything in a block that is actually announced. That is actually pingable. So you can sort of gauge whether it's like over a darknet where it's like, just sitting there announced going into a black hole, or alternatively it's a CGNet where nothing would respond anyway. Or, if it's actually running services or actually has real customers behind it that would normally respond to a ping. Reverse DNS as well. Reverse DNS gets scanned basically every time the zone gets rebuilt. However, there's a couple of other fun things. Reverse DNS scanning also works on IPv6, where you can go and hunt down a bunch of stuff in the vast IPv6 space, assuming the DNS server is RFC compliant, which most of them are, you can find a whole bunch of things hidden away in networks that not all network administrators thought that you could see. So I recommend occasionally going by through some DoD space and finding their Prometheus. Not that you can access it, but it's interesting to know that they use Prometheus. Another cool feature is I can also show you the forward DNS data. So I can show you what points into a prefix. So if you're theoretically, if you're looking at flow logs or something, and you say, hang on, there's a lot of data going into this prefix, and I don't know what's going through there because I have no DNS log or whatever, you can go into the forward DNS tab, and if there is something there, you can see what DNS names would resolve into there. Obviously, you cannot work with GeoDNS, but gives you a nice idea of like what is pointing where for the most part. Another fun thing, anycast detection. Given anycast is seemingly growing in popularity and how that anycast doesn't really collide very well with the idea of country flags, anycasts are automatically detected. The way this works is I have an anycast of my own, and if you send a ping from every single anycast node and you get a response back individually on every anycast node itself, you can be relatively sure that the ping that is coming back is local, and thus it's probably an anycast. If all the replies land back on one node, it's probably unicast. And so this data is done every 24 hours or so, and then pushed out to a Git repo so you can see how anycasts are changing over time. There's an API, kind of. APIs scare me, personally. The idea of making sure that someone's scripts keep working for the next 5 years is utterly terrifying. So I've been pretty skittish on adding any kind of APIs that give anyone real data. But given that people will always ask for it, there is a Whois server that acts very similar to Team Cymru's, but it's in UK. So if you're using it in the UK, it's relatively instant because of latency. There's also just general table dumps that you can ask for that tell you how many times I've seen that ASN, where their prefixes are. We'll get onto that later, but there's also a dump of ASN names, which will be my next rant coming up next. And if you really, really hate yourself, you can also access bgp.tools over Gopher. It was done for an April Fool's joke, but decided to keep it because there were a few people actually using it. So you may be thinking, this is all very well and nice, but how hard can it be? How hard can it be to make a site like this? And this is generally what the data flows of bgp.tools looks like. So a whole bunch of, there's generally 3 data sources. Whatever goes into MySQL is the sort of lives on for more than 24 hours. Things like Whois and peering DB information, Chrome, the snapshots from websites all live in MySQL. And then you have Redis, which contains the more sort of volatile data, things like the MAC addresses and whether things are anycast or not, because that can change relatively quickly. And then finally, there's the actual BGP data, which we're going to get into shortly, which is actually a newer custom data format. This way, in that architecture, is actually remarkably cheap to run. MySQL runs at less than 13 gig of storage. RAM usage on Redis is very low, although we'll get into that later. And generally speaking, this data is very small, very cheap to run. The website is pretty fast, assuming you're in the UK, because if you're using it from the US, there's the speed of light problem. You might be wondering what's the hardest feature to go and do all this, and why this project continues to take up so much of my time since 2018. It is this. Not Akamai. Akamai is not that much of a problem. Although, that being said, actually, the access denied thing is extremely annoying. But that's a separate problem in itself. It's actually the naming of things. So taking a Whois blob and turning it into a name seems like one of those things which would be very easy, but is in fact so difficult and so finicky, you will genuinely lose your mind doing it. Picking out and turning in these lovely blobs of text into sane and readable names that normal people can identify. This is a pretty easy example. So this is my ASN. You can see if you just take the org name, that's what the website uses. However, if you were to reuse that logic on appnik, in this case, it is a sponsored ASN, a sponsored appnik ASN. So the org name here is VMhouse. However, VMhouse doesn't own that ASN. It is sponsored on behalf of the actual owner. And so if you were to do that, then all of the ASNs in appnik would be owned by their sponsors, or be named by their sponsors, which is not particularly helpful. So instead you have to sort of rummage around to try and find some other name. Hopefully they put one down, because normally they do. Alternatively, you just get servers that are just a bit more bizarre. The Lacnic one sends you double Moji bake, so the text is so broken it is actually undecodable. I have emailed them about this. There's no real workaround. It just will always send you back slightly corrupted data. Alternatively, you get the JPNIC one, which kind of sends you this beautiful ASCII art view that is not very parsable, but it's very pretty. Have to parse it anyway, but it's very pretty. So there's a lot of unique text processing challenges. There's no real machine-readable formats here. In case anybody is feeling like doing this, I'm going to give you some warnings, heads up, about my adventures in Whois. Effectively, give up hope. It's going to take you so long to get this right. However, so that you don't have to give up hope, you can actually just steal it directly from me. There is a dump here that will just give you an ASN to ASN name prefix. Sorry, lookup table. Free to use, I guess. There's no license on it, but free to use. The second hardest feature of BGP.tools is, unfortunately, BGP itself. So the standard data sources for websites like this are things like the University of Oregon's root views and the RIPE-RIS project. BGP.tools used to use these services, projects. However, eventually kind of hit the limits of their ability. One, the MRTs, which is the standard data format that these things produce, are only produced some of them produce every 3 hours, some of them produce every 6. And when you're debugging stuff in real time, you kind of want the data there instantly. So that's just not really possible on these services, if you want to. And there's data accuracy concerns, where I am more neurotic about monitoring the state of my tables. Sometimes these services, because of the way they are run, they're university projects or less important projects for these companies, not really well looked after, in my opinion. So I built my own BGP collector sometime in March, and slowly managed to get out. Launched it at RIPE. I now have about 400 people feeding me tables, which is extremely appreciated. The way this daemon works is kind of fun. So it's once you throw out the idea of actually having to produce and insert things into the data plane, BGP becomes a lot more bearable. No real convergence times, no real thinking too deeply about how things work. Just storing tables is really quite easy, and you can build a specific daemon for the things that you're looking to do. So BGP.tools, I'm very rarely asking questions like, what is please give me all the roots for this prefix. What I'm actually asking is, please give me all of the upstreams for this ASN. So this daemon is actually much more focused in calculating that exact answer than calculating a whole bunch of root AS paths. This is relatively scalable. Every single session runs in an individual process, so it can crash on its own. And a feature that was very appreciated during development. And seemingly has proven itself at high capacity, given occasionally people DDoS me. Falsehoods programmers believe about BGP. Pretty much a lot of these are so powerful. Whois is such a powerful entity. Whois actually corrupts other subjects. So the fact that a lot of BGP announcements just have no records attached to them whatsoever. I'm not talking about bogans, although there are a few bogans. Instead, there are just things that should not have been announced at all, and you sort of question how they get there. The answer is, occasionally people can announce 10/ into the DFZ, and somehow that gets through. Standard things here, like prefixes are only originated by one ASN. We've already covered that. Thanks, VeriSign. Upstreams are easy to detect. Sometimes people have this weird relationship with their upstream providers where sometimes they're peering in certain regions and sometimes they're not. This is really hard to determine automatically without going too deep into things like community strings. My favorite one, and this literally stole me, it's ruined one evening, pretty hardcore, that there is only one AS path per BGP update. So it is theoretically possible for you to put 2 AS paths. Well, there's nothing stopping you in the protocol from doing so. Putting 2 AS paths in a BGP update. And the normal way you do this is that there's an internal confederation is actually transmitted separately. But I actually found one Polish ISP that somehow managed to announce a prefix that had 2 normal AS paths in them. And of course, BGP has no, up to the implementation. Unfortunately, my implementation disagreed with literally everybody else's and spewed a ton of corrupted data into the BGP tools. So yeah, if you ever write your own BGP implementation, watch out for, I guess, the rest of the internet. Although I guess that's always been the name of the game, hasn't it? Some providers insert private ASNs into the AS path. You've got to be careful about these people because they can break all your peering relationships or all your peering relationship calculations. And stuck roots are a continuous problem. So people who, when you withdraw your roots, some routers just don't get rid of them. But they continue to announce them down to stream to peers, so you get this weird view of legacy garbage roots on certain networks. So one of the advantages of doing this is that I have now complete control over my own BGP data flows. This means I can do things like, wow, that's really particularly glitchy, isn't it? Basically, I can do things like real-time updates. So in this case, I am briefly changing the policy. I'm basically enabling NTT on a certain prefix. There you go, I just done it in everyone's favorite cluster SSH. And you can see on the website in real time, as that prefix, as the website gets told by all of the other feeds, that NTT is now available on that you can now use NTT directly to get to that prefix. It is BGP convergence speeds, so it still takes some time, but you are at least seeing how things slowly converge out. So now you can see that NTT is recognized as a direct upstream. That's probably it. The other things it lets me do is build things like monitoring services. So certain individuals and with exchange of money, you can pay me to do monitoring. I can do relatively quick and rapid response monitoring now, similar to bgp.tools. Similar to bgpmon. So if you remember that, can do a whole bunch of other database monitoring stuff as well on top. The other thing I can do with this is if you feed data to bgp.tools yourself, I can display you on the actual map. So in this case, AML, Cyclone, and Monsoon are my routers. You can see how those routers on the propagation map actually get to somewhere. This is also updated in real time. So if you want to go and if you're changing your export or import policies, or like preferring one carrier for outbound transmission, you can keep this window open in real time and see stuff shift around to see if the policy has actually done your intended effect, rather than continuously polling against your own router. Doing this is also it's mostly frictionless and easy. You can log in through PeeringDB if you have a PeeringDB account, or sign up directly into bgp.tools. We only require one contact method so that I can contact you if something goes horribly wrong. And you can instantly create sessions. You don't actually have to email me. It's entirely self-serve. This is all you need. Basically, a description of the session, ASNs if you want to do IBGP or eBGP, and if you absolutely need it, I really don't want you to do it, but if you do need it, an MD5 password. The other thing we do is we will at some point be exporting MRTs. We front-load consent, so not everybody wants their tables to be shown globally or exported globally. So for this, you can actually specifically consent into having other people see your tables or be able to download your tables. And there's a secondary one for whether you would be OK with a commercial entity using those tables too, like another third-party entity using those tables, just to split up the concerns that some people have with dumping their tables out. If you like this tool, please set up BGP collector sessions. I'm in particular need for Orange, Verizon, any of the Verizons, Deutsche Telekom, Telefonica, and Sparkle feeds. They're just hard to come by. And if you want a better sort of clout, I guess, to show on your page to potential customers, you can make that peering number bigger, because if I see directly from your network, I can see who you directly peer with. Customers like bigger numbers, right? It also helps, more importantly, the academic community get access to more realistic BGP data, so that when they write papers, they're writing papers more grounded in reality. Questions, requests? Yeah, I'm ready to take questions.
Thanks, Ben. Anybody have any questions on the floor? I can't see everybody all the way around the back, so if you're around there, come this way. So if nobody else has a question, I have a question. There is some kind of commercial model behind this. How are you going to sustain this as a business if that's what you're doing?
I'm trying not to starve, is the answer. Yes, effectively there is some commercial offering if we go the way back. This is currently it. There will be more things in the future, but I just haven't gone around to it. It's a one-man band. I'm just trying to sustain myself, really. Yeah, there's nothing much really more nuanced there. I sell monitoring services. You can go onto the site and see how much it would cost you. Hi.
Hi. Well done. That looks amazing, by the way. Sorry, Charlie from CommsWorld. I've been poking around on it while you were talking. Tell me how you calculate upstreams, downstreams. Those relationships are quite hard to figure out. I was looking at RASN and I couldn't quite...
Did it tell you that Sprint was your upstream?
No, it told me that a customer was an upstream.
Oh, fascinating. In which case you probably have a root leak that it's detected.
Right, interesting.
Yeah, talk to me afterwards and I can hunt it out for you. This is a tool that is exceptionally good at finding root leaks. Much to my maddening, because normally I'll look at a network being like, okay, I've deployed my change. You look at a network just to test it and you'll be like, is that real, or is it just detected a new unique root leak?
Awesome.
So
right, well,
what's probably happened is
right
one of your customers have accidentally exported it, or some other, yeah. This happens surprisingly often.
Take my money. Thank you.
Nothing more? Nothing from Mattermost? So Mattermost polling, please, if you have anything to say. Ben, thank you very much
Thank you.
indeed.